Hi, and welcome back to ScottiesTech.Info. I'm Scotty, my co-host Cletus. Today I'm going to talk about one of my favorite gizmos. I have a lot of test equipment and that sort of thing, and I have a couple, digital multimeters and that sort of thing. But there's one in particular that is super, super handy. That is this guy, the Voltcraft LZG-1. This is actually it's a multimeter, but it comes with this guy. As a multimeter, it's kind of okay. It's not very good, blah, blah, blah. But the important part is this, which works along with this guy. What it actually is a wire tracer. A cable, there's another name for it, but I call it a wire tracer. So what exactly is it, and how does it work? So what it actually is a wire tracer. And how it works is you take this guy, and this guy has a ground connection, and then he has these, and you notice that each of these little alligator clips has a number on it. Like this one says like 10, and this one says 2, this one says 1, and there are 16 of them. So the idea here is that you take, if you have a ground, you connect this to a ground or a water pipe or some common connection between point A and point B, and then you have 16 of these dudes that you can connect each to one different wire. And then on the other end, you have these guys, and when you turn this guy on, and you connect these to this one to your ground and this one to each of the wires you want to trace, it completes a circuit from here through your wire to here, and it will show you the number. So if you have, like, say, number 11, it will show 11. So let's do a quick little example of that. So this is your wiring harness, right? And you've got, I only have 2 wires here, just to demonstrate exactly what it does. So on one end, you're going to say, this is your ground, and this is your number, that's number 11, let's do number 14. So there you go. And on the other end of your wiring harness, over here, you clip these dudes. Again, we use blue as ground. We hook this guy to the red one, and you'll notice on our display, if we turn on our transmitter here, it shows 14. So if we have another wire, we could say, let's hook up number 2. It shows 2. Hopefully that's fairly visible. So, okay, you notice this guy, your remote unit here is blinking. So, right, but what's the deal then? It's kind of confusing. Well, let me draw a nice little picture here. So, the whole idea is that you have, say, it can be junction boxes, or say you have a wiring harness in like a car or a tractor or something. So you have like connector there, and you have all these wires going in your wiring harness. And then let's say you have this is like your engine block. Let's say it's an automotive application, let's say, right? So then what you do is you take your little black wire here from both ends of the gizmo, the actual remote transmitter unit and the receiving end, and you take your black wire, like this is your big unit, and this is your little transmitter. You connect the black to ground, black to the engine block, and then on this end, you can either remove the connector or you can stick some little wires in here, and with this guy, with his little alligator pigtails, you connect him to every single one of these wires. And then on this side, you have your black alligator clip going to ground, and your red one, you connect it first to one, then to the next one, then to the next one at a time. And this little display on here will show, as I just demonstrated, the number of your wire. So the whole point here is like this one is 6, this one is 7, this one is 16, etc. So, okay, so the whole point here is that with this guy, you can trace wires, right? There's many different ways to trace wires. You could say, if you have, say, a wiring harness, you could connect, you could short, like you have 2 wires and you want to see if there's continuity in this one or something. You could have long leads and use a DMM and test for continuity. If it's a very long harness, or if it's junction boxes in a house or something, you could connect 2 wires together and test at one end for continuity. You could get a buddy and say use like, I don't know, maybe like a 9-volt battery if the wire run isn't too long, and you could put a 9-volt battery across a pair of wires and you can measure a voltage at the other end. There's various ways to do it. There's various gizmos that let you do this. This one is particularly good because it measures 16 wires at a time, first of all. Second of all, the way that it does it is pretty nifty. So I took this guy and I hooked him up to my oscilloscope, and what it actually does, in order to get these different numbers displaying on here, what it actually does is it outputs a 5-volt square wave. So if this is 0 volts, what it's actually doing for wire number 1 on your labeled wires here, you know, for wire number 1, what it's actually doing is it's just outputting a 50% square wave, 50% duty cycle. For number 16, it looks a little bit more like this. So it's actually quite nifty because it's not DC and it's not AC. This is actually 5 volts. This is 5 volts, and this is a 50% duty cycle. And this one is probably close to 100%. It's probably like, I don't know, maybe like 95% or something. A couple little details. You have to make sure that the power is turned off. So you have to say if you're testing an automotive application, make sure that the engine is off, batteries disconnected, everything before you trace your wires. I actually use this guy. The whole reason I bought him was because of some friends of mine. They bought a house, and they had an issue where basically the circuit breakers, when one breaker would trip, other breakers would trip. And I kind of sat there and looked at it and went, well, what's the problem here? This is a little weird, right? And I concluded that basically what was happening is you had 2 pairs of wires coming out from the breaker panel, live, neutral, and then those were going into a junction box, and you have live, neutral going out, right? Now, normally in the junction box, these wires would be connected together like that. But that's not what happened. What actually happened was this neutral was connected to this neutral, and this neutral was connected to this neutral, which meant the lives were connected straight through like they should be, but the neutrals were swapped, which you can't do with a differential/GFCI breaker. And this was causing all kinds of craziness. And it was this guy that I used to trace, because I could start with him. I cut the power, start with him, and I've got 16 wires I can test at a time. I only needed to test, I think it was three circuits were running through that junction box, so I figured out which circuit breakers they were, connected this at the breaker panel after turning everything off, and then I used this guy at the junction box, and I was able to trace, and the little number appeared on here, and I went, they switched the neutrals. So I put it back the way it's supposed to be, and poof, problem solved. Now, this guy, this is, as I said, a Voltcraft LZG-1. This is available from Conrad. Conrad in 1991, I believe it was, they stopped shipping to the US and North America, US and Canada. Fortunately, this Voltcraft LZG-1 is available from Conrad. Conrad is available in a whole boatload of countries, and they will ship to, I think, over 210 countries except the US and Canada. So I'll put links down in the description if you want to buy the Voltcraft LZG-1. If you are in the US or Canada, you cannot buy this Voltcraft, but you can buy the Extech CT40, which looks surprisingly like this, except instead of gray rubber coating, it's orange, and it has an Extech logo instead of Voltcraft, and it's called the CT40, but like it's exactly the same thing. It looks like exactly the same manufacturer. They just put it in a different package and changed the name and said, here you go. The Voltcraft LZG-1 is available on Conrad for about 80 euros. The Extech CT40 on Amazon.com is, I think, 85 US dollars. That's a little bit expensive, but keep in mind it's extremely handy. You can trace a whole entire wiring harness. I've used this before on, it was actually a tractor that needed to be fixed. We needed to redo some of the wiring, and tracing the wires using this thing was incredibly, incredibly handy because I could work alone myself. It just makes it very, very quick. And as an added bonus, you notice that you have your traditional DMM testing leads on here. This guy is also a basic DMM, a digital multimeter, and you can measure voltage AC, voltage DC, resistance, and it's got a little continuity tester. As a multimeter, it's not the greatest. The accuracy is okay. It'll work. The big problem is it's a little bit pokey when making measurements. I mean, I'm used to having, I have another Voltcraft multimeter here. This was a much fancier one, and he's a much quicker and more accurate and that sort of thing. But as a basic multimeter, it works. Unless you're doing some high precision stuff, it works. So $80 might seem like a lot of money, but as I say, the wire tracing part of it is extremely handy, and you also get basically an inexpensive multimeter that it does its job well enough. So it saved my life a couple times. So yeah, that's about it. Like I said, I'll put links down in the description. So if you wanna grab one, it works very well. And yeah. So if you have any questions or comments, leave them below. For more techie tips, see ScottiesTech.Info. Thanks for watching. See you next time.